show this. Okay, so I am recording. All right, so let's switch cameras. We're starting. This is Career Math on Tuesday, February 8th. And let me switch cameras. Okay, so there's two big ideas in this chapter. We're going to be talking about this one. So the first big idea was compounding. If you had the formulas, and remember we said if you do it daily for a year, okay, if we did daily for a year, we would have, you'd actually have to do it like R is 1 over T times and that many times to do it. And it's like, well, we have this 1 over N times that many times. Well, why don't we just make that a new variable and we call it the number of times compounded annually, okay? So if we're doing, so there's a table here, okay? So this table, so we said we start with yearly, we end up with N equals 1. Oops, right here. And if we did semi-annually, N equals 2. Quarterly, if you're here, I have it over there on the board by the U of A sign. Quarterly, N equals 4. There is no 8 times a year. Then it usually goes to monthly, which means N equals 12. Then we usually go, what's unit of time is smaller than a month? So quarterly is 3 months. This is every once a year. 1 year, this is half a year. This is a quarter of a year, which is 3 months. So 6 months and 3 months. Here's 1 month. So 12 of them in a year. Now here's where it gets funny. Months aren't equally length time. Usually 30 and 31 days, kind of the same. But then you got February, which is 28. Sometimes 29. So usually what they do is what's unit of time is smaller than a month is a day in daily. And daily usually say N equals 365. Okay. So now remember, oh, no, I didn't. I forgot there's one between that. What's bigger than a day and smaller than a month? A week. Weekly. That tells you N equals 52. And then there's daily. Daily, N equals 365. Okay. And okay, is that showing up? Is that in focus up there? Can you see that? Do you see this? There's a fuzzy. How's that? Yeah. No, okay. Well, you have this in front of me, right? Okay. Because that's what I'm looking at. Because then in the internet, then when I record it, it flips it back over in the video. So it's like, oh, crap. Okay, yes, that's a problem I'm going to have to deal with. Okay. Okay, guys in internet land, when I look at this, I see the mirror image of this thing. And unfortunately, I got 2 people in class. Here, I'm used to looking at it like that. I usually ignore it just to check if I could see it, if I got it centered and focused. But here, okay, you guys up there got to read it. Can you get by with this for a while? Okay. I'll figure it out tomorrow. Actually, next time we meet. Yeah, okay. I'll figure out how that goes. because I'm going from here to, all right, I got to sit down and play with this. Actually, I don't think I could fix it right now. I'd have to stop and think how I do it. Okay. Okay, well, anyway. Let's go with the flow and then we'll watch the video tomorrow. Okay, so remember we have our 1 equals, this B equals P, your principal that you put in. Remember, this is your 100%. It turns out this number right here is the monthly, the time, how much interest it earns in that one period. So because this is daily, this is 1 day's worth of interest. But how many days, but we're doing this for a year, how many days is that? Well, you got to multiply it times 365. Okay. So when they talk about the APY, so the APY is, so AP, so this is the, so remember I talked about the A percentage APR, which is annual percentage. Oops, that's an ugly looking R. That's a rate. Okay. And then we have the APY, which is a yield. And it was like a yield is, remember, is like if you have some money and you grow it, how much it grows is the yield. Now, do we want to do the compounding business? But at the end of the day, was we want to know what we put in at the beginning and what we got out at the end. And what did I do to the stuff at the beginning to make it what happened to the end? Okay. And we did this compounding. So like here it says, what's the ending balance? This is just practice for the ending balance. I talked about this last week. What I'm going to talk about it a little bit differently here. Talk about the APY, because there's going to be some problems where they talk about APY. So remember, when you're plugging it in, this right here, this line right here, that's what you got to type in your calculator. So remember, if you take it, raise it to something, and remember, put it in a parentheses. Now, some of you guys got decent calculators. I was looking at somebody, was it you? That had a, no, somebody, 5th hour. Somebody had an Apple calculator. And if we were trying to do it like this, it was like, oh, good God, it was awful. So you're better off to calculate the pieces. So like this would be kind of easy. Okay, calculate what is 365. Okay, so it'd probably be better off to write it down like that. And then you say, okay, what is that? So you go 365 times 3. And you go, okay, 1095. Okay, that's 1095. So when you raise it power, you raise it to how many days are in 3 years? 1,095 days. Okay. And so now you're going to say, okay, so now you can calculate this, raise it to the 1095 power, and then do this bit. So actually, when you're calculating it, if you got a cheapy calculator, it's probably better to work backwards. Because, okay, so now you do 1 plus 0.03 times 3 to the over 365. Then you go, okay, 1 plus 0.03. There's my 3% daily. So I earn, a really teeny tiny amount of interest. Okay. This would be 10%, 1%. That's a 1/10 of a percent, 100. So 0.008 of a percent a year. I was like, that's a teeny tiny amount. But you're doing it 365 times a year. So if I wanted to do the annual percentage rate, I go times the yield. I would do it for 1 year, and it was like, oh, it'd be 3 point, and then remember times 100 minus 100, or I could just subtract the 1, because remember this is 103.04%. Okay, this is a small 3%. Is kind of small. If you compound it daily, it gets bigger, but not by much. Okay, so if I subtract the 1 from it, so what, minus 1, and then I go times 100, it'll be 3.04% versus just a plain old 3%. So it's a little bit bigger percentage-wise, but not by much. Okay. So if I was to take that number, I took this number Okay, this number right here. Okay, so let me delete all this one. Okay, if I took this number and I multiplied it by 1650, that's how much interest I would earn in a year. Times, oops, go down here, times 1650. Yeah, looks like I get to 1700. Nope, that's not right. Answer is something else, actually. Let me clear that. Oop. Let's do that one. That times 1650. Okay, 1700. Now, if I took that and raised that to the third power, like I was doing here, okay. So instead of raising it to, let's see, what was it here? Yeah, this number, and I raise it to 1095, okay, and then you multiply it by times 1650. So at the end of the first year, you have $1,700. Well, it looks like it's gone up $50. The end of the second year, you must go up another $50, which would be $1,750. And the end of the third year, it's $1,800, and then you get an extra $5 of interest for compounding daily. Okay, so yeah, it's $150 more, which is like about $50 a year. Okay, so the annual percentage rate, the API, the APY, so APY plus 100% is going to be 1 plus R over N to the N power. Okay, so R over N to the N power, which is kind of this bit. But remember, if we're doing for multiple years, we got to multiply this exponent by how many years we got. So it's NT. But we just want to do it for N. Okay, so APY plus 100%. So like here, this was what it was the APY. So the APY was what 103 point. What do we say it was? This number right here, 103.046%, which is 3.046% is our APY. Okay, that's the APY there. If I just said raise my 1,600 times that percentage, it will get to me what I have at the end of the year. It's basically okay. So 1,650. Oops. Yeah. Okay. Wait a minute. All right. Yeah. So yeah, 1,650 times 1.030456, and you end up pretty close to 1,700, which is what we got up above. Okay, so we end up doing the same thing here. All right, so that's the big thing, is calculating the APY, and it says, and we're just practicing calculating compounding and then calculating the yield. Okay, so investigate the difference between compounding annually and simple interest. So simple interest compounding, that's going to be the complicated formula on the front, and simple interest is B equals P times 1 plus RT. Okay, 1 plus B over part RT, which is over there on the board. One of the boards over there it's up there on top, up there by PEMDAS, up there. Okay, and then we had B equals P times 1 plus R over N to the NT. Those are the two formulas they're going to be talking about. So simple interest, we'll use this one. There's my P, there's my R. In 1 year, there's my T, one. Okay, so plug it in and crunch the numbers. Interest rate compounded annually. Well, if you compound annually, it says over 1 and then 1 times 1. This is like there's like an invisible 1 exponent. It should be the same. Okay. Simple interest for compounding, well, it's going to be 3 times that number. Simple interest for 3 years, it's going to be 3 times the 1 year interest. You know, it's like that's kind of the simple the rate here. But then if you do compounding 3 years, well, then the interest earns interest, and now this is going to be bigger. Okay, so for a 6-year CD, if 6%, so T equals 6, P equals 5,000, R APR or R is 4%, 0.04. But then you do it compounding simple versus compounding. Well, the compounding will be the interest starts earning interest. And then it says compare G to H, who's bigger, who's smaller. The compounded annually be smaller. Is compounding annually simple the same as simple? Well, no. Why? Okay. The Y is, remember, I've been harping on it. What is compounding? Interest earning interest. There's your Y. Okay. And this one is just basically they give you the same thing here. Rodney invests P money. Let's P equals $1,000 at a rate of R compounded yearly. Gerald, okay, so Rodney and Gerald invests half the money, so half of 1,000, and it pays twice the interest rate. So if I cut the half the amount, but I double the interest rate, what I get, is that kind of the same thing? We'll find out. Okay. And this is, and it says compounding after 1 year, so T equals 1. Okay. And so after 1 year, okay, so you should see, so there's certain times when the growth rate gets cut in half, you'd have to increase the principal by how much? Okay. Well, if it's a straight relationship between the principal and the rate, I double this one, I can cut this in half, and I end up with the same amount. Well, we'll see. Okay. So actually, you need to do this thing. So you'd say R is, so $1,000 times 1 plus 0.05, and it's compounded annually for 1 year. So 1 times 1. Okay. But then Gerald equals half of the 1,000, so 500 times 1 plus, but then the interest rate is twice as big, so 0.10% per year raised to the n times 1 year. Which is bigger and which is smaller? Okay, that's what you're basically plugging into the calculator here. Okay. So R equals 1,000, 1 plus 5%, N is 1. So R, N is 1, and then Gerald, or Rodney, he compounds it annually for a year. So here's a compounding annually is these two numbers, which are N, for a year. That's the second one. So compounding annually, that means N is 1. And then for 1 year, this is T equals 1. Okay, so that's basically a version. We're coming back to here as Rodney's $1,000, and then one has 5% and one has 10%. Cut that in half and then double that number. They're both results the same. So like here, Rodney will have some amount of money, Gerald will have some amount of money. How do they compare? And that's what you're kind of explaining there. Takes out a 1 year, and usually when they're talking about these, they're talking about the 14. when they're talking about yield, they usually do it for 1 year. Okay. It's a little more complicated than that, but you have to do it for a year. If you do it a multi-year thing, like I was doing on the example on the back, you got to be careful. Well, here they're not. They don't want to. If you become a master of business administration, an MBA type, where you know about financing money, you will know this inside out and forward and backwards. But for now, yeah, okay, you just need to kind of see it. It's just the yield would be a yearly simple interest net deal. Okay. It's just like, how much would my money grow for a year? It's basically 100 some odd. It's like a growth. What percent of that? That's my interest. That's how much it grew. Okay. How did it get to that growth? Okay, compounding, which is a complicated formula. Just this type of formula here. And so now it's just a matter of crunching them out. So PR, there's my P, compounding, N is 365. Okay, so I'm looking for this key phrase, compounded. Compounded what? Daily. That's the key phrase you're looking for. And if you look at them, okay, if you look at it, compounded, if you look at the reading for these, there's really only almost one way to say it. Compounded what? So that tells you N is 1. Here, compounded daily, N is 365. Compounded, okay? So compounded, it's like here, interest on number 12, J. It's compounded annually. And there's really, if you read all the problems, they'd have to get really convoluted. So like here, there's our J, compounded annually, compounded yearly. Annually and yearly are the same thing. N is 1, N is 1. Okay? And so English, you usually have a lot of ways to say the same thing. Well, for compounding, there's really not. I mean, it earns interest every day, maybe. It earns interest once a year. That could be compounded. That might be a different way. How could you say that? The only way I could other say was like it earns interest once a year. Earn interest every day. That might be another way to say compounded daily, I think. But it's not very common. Usually they say compounded. Okay. And that's really P. This is T equals 1. And so now it's just a matter of like, 1 year. There's my T is 1 year. 40 grand. That must be my P. There's my, I can actually tell you, APR. There's your R. What else do you need? You need RN, yeah, P, R, N. There's 5 variables. You're solving for B, but you got 4. B, your principal, your annual rate, your compounding period, and your time. 1, 2, 3. And there's my N. So there's my R, there's my T, there's my P, and there's my N. That's all you need to know. And just plug it into the formula and crunch it out. Okay. Yeah, businesses. So 15, business put a ton of money. Imagine with an account with $10 million in some of these giant corporations, they have that. Well, like Apple has an account. They actually, on cash on hand, I think they used to have, 10 or $20 billion. The cash they had was in the billions, which is like huge. Okay. Well, like Motorola or the coal company, when it was in its heyday, it might have had $10 million in cash, maybe. Okay. APS that runs the coal plant up here by Page. They might have, they're a big company, hundreds of millions of dollars. They might have an account with 10 million bucks in it, something like that. A big company, really big company. The railroad, okay. Burlington Northern, okay. So how much would it earn in 1 year with simple interest of 5.2? But if it was compounded daily, so here, compounded simple interest. Well, this is Simple interest is like a way of saying compounded annually. Okay. But if you do it for 1 year, compounding simple interest and compounding annually are the same thing. Okay. But if it's compounded, but if you're doing it for more than a year, then you have the interest as assurance of earning interest. Okay. But compounding daily, you earn a little bit of money interest and goes daily. But 10 million, you could start getting serious money every day. Okay. An elite private college. Okay. No, yeah, some of these are actually, this is actually, and back in the day, this is probably about accurate, but now some of these elite, like Yale and Harvard stuff, they have like a billion or two. Accounts have a couple billion in them. And it was like, why are they charging? Why are they so small? Well, yeah, well, because they have the elite name and in their networks. Yeah, so, but they could get by without charging anybody a shred of interest, and then they could go gold plate their toilets. You could have solid gold toilets in the place, and well, not that many of them, but gold plated toilets for sure. Um, and drinking fountains and everything. Okay. But solid gold, maybe not. That's probably $500,000 a pop. You can only have. So anyway, $1,000,000 a pop. You can only have a few thousand solid gold toilets. Eh, anyway, um, but they could do something silly like that. So basically, how much do you think are 1 year? So P, so this is T is 1, simple interest. Okay, so that's, you could say N equals 1, and then there's your APR, here's your R. Okay, and it was like compounded daily. So this is PRT, 1 plus, this is your B equals P times 100% plus your RT. Okay, that's what simple interest is. And okay, and if you're in the room, I got the simple interest formula up there on the board, back up there. I don't know, that pink chalk thing. Can you guys read it from here? Okay. Well, I guess with my dirty glasses, I need to clean my glasses. So yeah, now I can read it without my glasses. I need to clean my glasses to see that. But that's really all I got for you on this one. I'm gonna stop recording here. So that's all I got. So now it's just a matter of